Part solute and part solution. This is another common thing, especially if you're dealing with a concentration of trace species in the environment. You hear a lot about, okay, how much of a concentration can we have of this contaminant in parts per million? What's the parts per million in the air of something? So generally parts can be measured by mass or volume. Most commonly mass, because it's easier to measure the mass of molecules. And then of course parts, they're both measured in the same units. Whatever you have the solute, obviously the solution you want to measure in exactly the same quantities. So yeah, this is by mass, by mams, kilograms, whatever, as long as they're the same units. And so a percentage would be a part of solute in every 10 parts solution, right? If a solution is 0.9% by mass, there are 0.9 grams of solute in every 100 grams of solution. A more common for environmental reporting is parts per million. Now, parts of solute per every 1 million parts solution. If a solution is 36 parts per million by volume, there are 36 milliliters of the solution in 1 million milliliters, or 1,000 liters, about a cubic meter. So yeah, that's my way to think about it. 36 part per million by volume, 36 milliliters, filling up maybe a tenth of a Coke can in 1 million milliliters, which is 1,000 liters, which is a cubic meter. So not very much. But usually you'll report things in grams of solute per 10 to the 6th or 10 to the 9th grams of solution. That'll be parts per million, per parts per billion. For aqueous solutions, we often approximate the kilograms of solution as just a liter of water. For dilute solutions, the difference in density between the solution and the pure water is usually pretty negligible. So it's usually a pretty good approximation that a kilogram of water is about 1 liter. Yeah, so you take the mass solute divided by the mass solution and multiply by 10 to the 6th to get the parts per million, or 10 to the 9th to get the parts per billion. And rare contaminants are often in this form. So let's practice. Express the concentration of aqueous. Again, let's take something that's a little more dilute, or we'll get some interesting numbers. Let's take a concentration of aqueous 2.0 times 10 to the minus 5 molar sulfuric acid in parts per molar by mass. Well, now in this case, let's again pick 1 liter. Let's pick 1 liter. So I have 1 liter times 2.0 times 10 to the minus 5th moles H2SO4 divided by 1 liter. And that gives us 2.0 times 10 to the minus 5th moles. But then we're doing this by mass, parts per million by mass. And so we have to multiply 2.0 times 10 to the minus 5th moles times 98.08 grams H2SO4 divided by moles H2SO4, 2.0 times 10 to the minus 5 moles H2SO4. The moles cancel, and so we get 1.96 times 10 to the minus 3 grams H2SO4. So we want it in parts per million, so we have to say how much, what's the mass of the solution here. So we can approximate the mass of the solution as the mass of just the solute. We got 1 liter, and so 1 liter times is 1,000 grams per 1 liter. And so we have approximately 1,000 gram solution. So the parts is 1.96 times 10 to the minus 3 grams divided by 1,000 grams. And that is 1.96 times 10 to the minus 6. So it's 1.96 parts per million. So this solution, which is 2.0 times 10 to the minus 5th molar sulfuric acid, is 1.96 parts per million sulfuric acid, not that much sulfuric acid.